we've been given or provided that the integral of 1 over x squared minus 1 dx is equal to tangent inverse of x plus c. Then we've been asked to integrate the square root of x divided by x squared minus 1 dx. Well, if you look at this very question, you can see that the question itself gives you a clue. We've been given the integral of 1 over x squared minus 1, okay, is tangent x plus c. So the first part gives us a clue that when we work to a certain point, then we can use the hard work, or we can use it to evaluate the integral at a certain point. Well, so without wasting time, let's set the ball rolling and see how best we can solve this integration. So that is what we have. So the integral of 1 over x squared minus 1 dx is equal to tan dx. Okay, that's what we have been given tonight. Okay, so this is what we have. So this is a function, sort of. So we are supposed to integrate this. Okay, we are supposed to integrate this. We've been provided with this integral, which is 1 over x squared minus 1. So we are going to take it step by step. So if you look at it, okay, what comes into mind, okay, is we can, because of the square root of x that we got on top of the whole thing, we can say that we'll let u to be equal to the square root of x. So let u to be equal to the square root of x. If we say so, and we square both sides, we are going to get u squared to be equal to x. Again, when we differentiate 2u du, will give us dx. So it makes our substitution easy. Okay, so what did we do? We substituted in the u, okay, to be equals to this, which is the square root of x, and x squared minus 1. Now, when we look at this very carefully, we say let u to be equals to s. Okay, so because of that, our denominator here, the denominator here, when we substitute the u, okay, our denominator, since x is equals to square root of x, and now we're able to break the x into to be equals to u squared. When we substitute this into the integral, we are going to get u squared all squared minus 1. So that will give us u raised to the power 4 minus 1. Okay. In the same vein, with this one, we can also write this one as u squared minus 1 to bracket u squared plus 1. Agreed? Okay, so now this is what we have. So if that is the case, then we are going to substitute everything we've seen into our integration. So then our integration will be, let me use, okay, that's it. So our integration now will be the integral u over the u 4 minus 1 as I put over there, and then our dx will be 2u du. Well, when we expand this, the integral will be 2 out integral u du all over u4 minus 1, which we can further expand. So let's expand this integration, as you can see over here. Okay, so we are going to expand it further. So this means that we can say that 2 out, okay, 2 out. But on a certain note, you see, if you look at it very careful, when we have 2u du, it wasn't even 2 out. So it was 2u du. So let's substitute that one carefully. Over here, where is it? Yes, this is 2u du. So that will make a u here, on top here, to be u squared. So this will be u squared. Okay, it will be u squared du. And when I look at this one very carefully, 2u du, where would our 2 go? 2 will come out of the integral. Okay, so we can say that 2 coming out of the integral, we will expand our u squared as that. Let's write our integral as integral 2u squared du all over u4 minus 1. We can also write this one as the integral. We can write as integral u squared plus u squared all over u squared minus 1 into bracket u squared plus 1 du. Okay, so that is how the expression term has become. So from here, let's go down, okay, because what I have done is I say 2u du, I said 2u squared du over u4, u raised to the power 4 minus 1, okay, and I've expressed it as the u, the integral of the u squared plus u squared, which is the 2u. Then the u raised to the power 4 minus 1, I've expanded. So I have u squared minus 1 and u squared plus 1. Now, the trick is, if we look at it very carefully, we'll say that we can split them. We can split them such a way that we'll be able to use partial fraction. But you see, in examination, when you've been given a question like this, you must always observe with precaution. Because see, the s squared minus 1 over here, yeah, the s squared minus 1 over here is the same as the s squared minus 1 beneath. But over here we have 1 on top, and here is root x. Okay, but here we have been given a clue to do this one. So as we have worked hard to get to this point where our integration of splitting or whatever, the breaking down of the integration is becoming smooth, let us do some kind of observation. Okay, now let me write the same thing, this one, again. Okay, so now when I say that, okay, then this is my integral. I'm going to write it like the integral of u squared, okay, and the u squared, okay, this all over my u squared minus 1 and u squared plus 1 du. Now, what I'm going to do is I'm going to subtract 1 from here. So when I subtract 1 from here and I add 1 to this, you see that I haven't changed anything. All what I've done is to what? This 1 and 1 over here, this minus and this plus, means the whole integral boiled down to be the same. Because 1 minus 1 plus 1 is always 0. Okay, so because of the way I've expressed this, then I can write my integral eventually to be that the integral, I'm going to split it. Okay, so now when I split this one, I'm going to get integral of 1 over u squared minus 1 du plus 1 over u squared. Let me make this one, okay, this plus, and this is u squared minus 1 du. Okay, now if you look at it very carefully, you see that we have finished the integration of that. Why is it so? Because we have been given that here, the u squared, let's underline this one, this 1 over u squared, okay, I've been given over the top. Now let's go to the top and see. So over the top, you see, we go up to the top, okay, it's the same as that, this whole expression. So here, instead of 1 over s squared minus 1, which is equal to tanh hx plus c, look at it. This is 1 over s squared minus 1 over u squared minus 1. So you see, this 1 over s squared, what we have over here is 1 over s squared, 1 over u squared minus 1. And our one that we've been given earlier says 1 over, that one is integral 1 over s squared minus 1. So which is the same as this. And we have been provided that that is tanh inverse of x. So this one, when we do the expression, we see that this, straightforward, when we integrate the whole expression, we are going to get minus tanh inverse of x plus c. So instead of x over here, it becomes u. You see, it becomes u. So it becomes tanh, yeah, inverse of u into bracket plus c. So now our issue is now with this. How do we integrate this? How do we integrate 1 over u squared plus 1? That straight on, we can also use the integral function. You remember, integral function of u squared plus, you know, we can write this, our integral here, as the integral 1 over u squared plus 1 squared du. Okay, remember we have a function that says if we have 1 over a squared plus s squared, yeah, that function, we can employ that function. You don't need to memorize it, okay? Because if that function says that if we have, let's remember this function. The function, integral function, is more or less like a formula. It says if we have 1 over a squared plus s squared, then we can say this to be 1 over a tan inverse of x over a plus c. Yeah, so we can use that one to evaluate this. Yeah, provided we say the x is our u. So over here, when we say if x is our u, okay, then our constant a is 1. Okay, then if we substitute that into the equation, then this will imply that the integral of 1 over our x is u, so, and our constant is 1, so it's going to be 1 squared, okay, 1 squared plus u squared. So if we say that, then that's the integral. This is going to be 1 over our a, which is 1, tan inverse of a, again 1 x over a. Then x, we know x is u, and a 1. Okay, so this gives us that. So straight on, this is boiled down to be tan inverse of u. So meaning we have been able to integrate everything. So our integration now becomes tan inverse of u plus minus, that is minus times inverse of u plus c. But we know u, as we started right from here, we substituted u to be square root of x. So that we say but u is equal to square root of x. So therefore, the integral will be tan inverse of root x minus tan inverse of root x plus c. So that is the final answer. You see, this is the final answer. Well, I think we got to go through once again so that we'll be able to break it into pieces for everybody to see how we started it. Okay, so let's go to the top once again. So the first impression, first thing is, we're given this as a clue to help us to integrate. And when we did that, straight on, we know that the root x over there, we have to get root of the root x. So we decided to substitute the root x here with that. So it became, this and that. So we say let u to be equal to square root of x. Then we square both sides of the expression. So we have u squared is equal to x. Then we realize that when we differentiate, because we need to substitute for the dx here. So when we did that, we had 2u du is equal to dx. All right, fantastic. So we have got our substituents that will help us to break down the equation easy. But beneath here, when we substitute the u squared to be x into the expression, the beneath here, that will be u squared to the power 2 minus 1. And that gives us u raised to the power 4 minus 1. Okay? Then we had this, u raised to the power square minus 1. We expanded it. Then we came down. We substituted all these respective values into our integral here. So we landed up with our u, which is there. Okay? So we see that we have u here, which is here. And u raised to the power 4 minus 1 multiplied by 2 u du. And when we did that, we had this expression here, which is u squared plus u squared, all over our fraction u squared minus 1 u squared plus 1. Now, I did a huge assumption because I realized I want to split the integral so easily for easy steps that it will make my answer arrive easily and quickly. So what did I do? Instead of this u squared plus u squared, I say u squared minus 1 and u squared plus 1. Well, I haven't changed anything at all. If I do that, all what I've done is I'm manipulated the integral. So after that, I got to this u squared minus 1 and u squared plus 1. So that's why I decided to put in different colors so that you can understand what I was doing. Now, with this, we know that if we even want to cancel this and that, we'll be left with u squared plus 1 minus that. So when I put it together, and we take a fraction of this, when you take a fraction of u squared, and u squared minus 1 as the product, when we simplify, we get back to this equation over here. So after splitting the integral, we knew that u squared minus 1 was given to us as a clue, as when you integrate, it gives you times u plus c, because we know that this is similar to x squared minus 1. So instead of u, we say x, or instead of x, we say u. So you see, this will become times u plus c. Now, after we have integrated the right-hand side one, I'm on the left-hand side here, this one. You see, we can decide to use the integral function that says that if you have integral, yeah, that's what it says. If you have integral of 1 over a squared plus s squared, can be written like that. So when over here you see we made u squared and 1 squared, which is similar to this integration. So when we substituted it back to this formula, we had 1 squared plus u squared, and our answer became 1, okay, over 1 tan inverse of u. Well, we know u is x, and our a is 1. And when we simplify, well, that's what we had. So after that, we put all the integrations together. So we had tan inverse of u minus tan inverse of u plus c. We have to be careful with this integration. We have tan inverse of u, and the other one is tan inverse of u, which were given from the top. Now, this became the final answer, but we made an assumption of u to be equal to instead of x, yeah, that the square root of x. Then after that, we substitute back to the equation. Then, lo and behold, this is our answer. Well, friends, this is where we can finish this integration x. To this point, you will realize that when you look at the question, it looks very complicated. If you look at the integration, it looks very complicated because you see you have been provided that 1 over x squared minus 1 dx is equal to negative times x plus c. They said then integrate square root of x all over x squared minus 1 dx. So when we did our substitution, eventually we went through step by step. We got to this fraction beneath the integral, which is u squared minus 1 and u squared plus 1, and u, instead of 2u squared, we say u squared plus u squared. Then we did a huge assumption over here, okay, and that helped us. It helped us to split the integral. So when we split the integral, we had this integral, okay, and our second integral, okay. So straight on, because we have been given 1 over u squared minus 1 du, okay, which is similar to 1 over x squared minus 1 dx, okay. So because of that, it made life so easy for us. You see, so straightforward, we know our answer to this is minus tan u plus c, tan inverse of u plus c. Then we also consider this one, okay, using the integral function, that says 1 over a squared plus s squared give us 1 over a tan inverse of x over a plus c. So we apply that as well, and we add this a tan inverse of u. Then we put them together as demanded. Then we have to replace u back, because u is not supposed to be part of the question. So put it back, and we have tan inverse. Okay, tan inverse of z x or root x minus tan inverse of root x plus c. Well, thank you very much, friends. This is where we will finish at. Please subscribe to the channel, okay, and also send it to your friends so that your friends will also know what we are doing. Have a blessed day, and speak to you again. Bye bye.